Hello friends, I'm Professor M. Bishinde from Senior College of Engineering, Pandharpur. I welcome all of you to this discussion. Friends, in part 1 and part 2 of acoustics and sound insulation, we have covered many points like acoustical terms, acoustical design, and acoustical defects like this. In part 2, last point was the insufficient loudness, which is one of the acoustical defect. Now we start ahead. Uh, One more acoustical defect is exterior noise or outdoor noise. We can say it exterior, outdoor. This defect is caused mainly due to poor sound insulation and partly due to poor planning, and this result in bad acoustics. The exterior noise or this nuisance is carried inside the room or hall or auditorium through loose doors, ventilators, window openings, and etc. This defect can be corrected or rectified by providing adequate insulation against sound for various components of the auditorium and through proper planning in relation to the surrounding. This is about the acoustical defect, and this was the last one. Moving ahead, the table shows defects and recommended remedies. Now you can find the solution for the each type of defect. Here you can find the solution. See, excessive reverberation is there, cause is insufficient absorption, then solution is provide the absorption, add it. Echoes defect is there, so causes unsuitable shapes, proper reflecting surface. So already I told you, unsuitable shapes means avoid the curved shapes. So here solution is given, avoid unsuitable shapes and make appending surface highly absorbent. Instead of plain smooth surface, go for the rough one. Sound foci, concave reflected interior surface, this one cause, avoid these curvilinear interiors. Add absorbent sound foci. Dead spot, irregular distribution of sound, because dead spot is what side effect of sound foci. Then what is solution? Provide even diffusion of sound or introduce suitable diffusers. What is insufficient sound volume? Lack of reflections close to the source. So this one the cause, source of sound or excessive absorption. What is the recommendation? Disposition of hard reflecting surface. This one is the solution. So here you can find the solutions for each defect. Now next one, acoustic requirements and conditions. The following point must be covered as far as the acoustical design is considered. These are the requirements. What is adequate sound intensity? It must be there, evenly distributed. The sound should be evenly distributed. Is it? There should not be present of any dead spot in sound foci. A clear and distinct sound should be clear, means clear pitch, clear loudness, means it should not be less than 20 cps. If it is less than 20 cps, you cannot hear it. This will be the sound of whisper, not clear. So sound should be clear, easily audible, reach the audience with the same frequency and intensity. Remember, how many number of audience present in the hall doesn't matter, but your sound should reach to each audience in same amount, in same frequency, in same intensity. And point one is last point is noise protection to be done. And if excess sound is there, excess sound creating the noise, in that case you have to go for the protection. Means you can add the absorbent, you can add the reflectors and all these things. Here this is the noise protection. Moving ahead, the factors in acoustical design. What are the factors in acoustical design? So first one is the site selection. Site selection, because before planning of every project, so first survey is done to be site selection. So in factors acoustical, what is site selection? In selecting a site for building which deserves the acoustical design and treatment, noises prevailing or foreseeable in that area should be considered for their effect on the acoustical conditions in the building. It is particularly necessary to keep the level of outdoor noise low by proper orientation of site selection. In case where no air conditioning is provided and doors and windows are normally kept open during the performance, is it? When air conditioning is provided, special care should be taken to reduce the plant noise and the grill noise. Remember, air conditioning means you are only going to provide the treatment, means for the easy functional requirement you are planning the, see, for our age we are planning the air conditioners, and if you see the noise produced by the machinery or plant of the air conditioning, that will be very huge. If that sound is transferred through the vents or air conditioning ducts inside of the building, it will be noise in that case, so it should be avoided. So these are the points that you have to consider in the site selection. If I want to add one more, some of the important sources of objectionable noise are automobile traffic on road, or busy street, we can say this highways, railways, airport, industrial establishment, whatever it may be nearby your site. In fact, the site selected should be in quietest surrounding. First, try to select site in quiet environment. This is condition. With other requirement to that, intelligibility of speech and total quality of music are not affected. This one you have to consider in the site selection. Second, we'll talk about the point volume, or I can say the volume cover the size and the height of room or that building. What is volume? The volume of room. The volume of room should be in proportion to the intensity of sound to be generated in it. Very important point. The volume of musical concert should be quite large so the sufficient space is made available for proper distribution of music. In planning the volume of hall, height is of greater importance than either length or breadth. Very important is height. We have to focus on height. If the, we'll cover these values in next slides also. If we are focusing on volume, suppose public lecture halls are there, so then volume is per person is taken between 2.8 to 3.7 cubic meter. If musical concert halls are there, the per person volume is taken as 4.2 to 5.6. 4.2 to 5.6. In cinema theaters, a per person volume you can consider between 3.7 to 4.2 cubic meter. So like this you have to consider the volume. In planning the volume of hall, height is of greater importance. Remember, height is of greater importance than either length or breadth. Next, we'll see the shape. Point is shape. What is shape? The shape of the room is more important consideration in the acoustic design of an auditorium, as it is governing factor in correcting the defects like echoes, sound posse, dead spot, etc., etc., which are due to the reflection of sound waves. For better distribution of intensity of sound, it is not the volume only, but the shape of auditorium also plays an important role. Remember, at the time of sound pussy, we have seen sound pussy is a point which may be created, or this is point where sound is focused due to the curve shapes present in the hall. So remember, flat shape, curve shape matters on the distribution of sound also. So intensity of sound also. The volume is decided on the total number of audience, whereas the shape is to be geometrical arranged in view of better audibility. So for shape, only point to be considered is better audibility. Usually, the shape of auditoriums expressed in terms of ratio of height, width, and length. So here we can take the ratio between height, width, and length of the hall. Normally in practice, the ceiling height for a room or hall to be used for speech and music is kept varying from 1/3 to 2/3 of the width of the room hall. This is normal rule. The lower ratio should be adopted for very large halls and higher ratio for small rooms. If your rooms are lesser in volume, in that case you have to adopt the ratio to be high, and if room is to be big big, in that case you have to adopt it low, like this. So suppose lecture halls are there, I can take the already I will discuss volume per seat is between 2 to 3 meter cube. Ratio of height, width, and length is to be taken as 1:1 to 1.5:3 to 3. Approximate capacity in persons we can say 150 to 300. If lecture hall is big, in that case volume is to be taken as 3.5 meter cube. Ratio height, width, length, it is taken as 1:2:4. Now how many persons can sit here? 400 to 500. See, size is changed. Suppose cinema theater is there, so little bit volume is increased. It is taken to be between 3.5 to 4.5 meter cube, and the ratio height, width, length is 1:2:3. How many persons can sit there? 800 to 1000. Same wise, theater or drama halls are there. Volume is taken between 3.5 to 4. Ratio 1:2:3, same like a cinema, and peoples can sit there up to 750, like this. Next one, fourth point is the interior surfaces or treatment given to these interior surfaces. See, the treatment of interior surface, that is ceiling and side walls, also play an important role in acoustical design. The ceiling and side walls should provide favorable reflections or reinforce the sound that reaches the rear part of large auditorium. Ceiling splays or spread outs, and approximately tilted portions of ceiling can be arranged or devised to reinforce the sound. In case of long halls, all reflections of the original sound must reach the listener within 45 milliseconds of the direct sound. Any sound reaching a person or him after 45 milliseconds of the arrival of direct sound will be heard as echo, because if this will not happen, then echo will form. So in order to avoid the interfering echoes, effective ceiling and wall reflected should be within 8 meters of sound source. So from sound source, at least you try to provide the sound reflected within 8 meters. So you have to plan it within 8 meters. If this happens, your acoustical design will be in proper condition. So to avoid sound pussy due to curved ceiling, the radius of curvature of the ceiling should be made at least twice the height, means height of the room, or less than the half the ceiling height, whatever it may be. Many other arrangements may be employed to minimize the objectionable reflections and thereby increase diffusion. So this you can consider. Detailed design diagrams we can see in the next further slides provided in this presentation. So friends, today we'll stop here for today's lecture. Tomorrow, means in next part we can start reverberation, setting arrangement, and sound absorption. Thank you.